often they make a mistake at it. And this is what we have in terms of what we're going to do. We're going to take this circle like this and wrap it around the x-axis. And so we have this equation. And what they will do is run from r minus r to positive r. But the problem is we don't have a derivative on the end, which your author talks about. Okay? And this problem, I think, is very close to, what I'm going to do is very close to what's in the book. So if you have to take a look at that, this is arc length. This will be your only question, I think, dealing with arc length on page 416. Okay, now, what your author does, he has this one, and we have done it, but you haven't used it very often. And what is the integral of 1 over r squared minus x squared, the square root of dx? And that's in your back of your book, and number 13 under integration. 13 under integration. Okay? And I will give you this one. So, and this is the inverse sign, like this, of x over r. Questions on that?
Where were we at here on
that?
The back one, number 13,
like,
the back.
Yeah, it's like the third to last page.
Yep. That integration. And we have done this one. We've done tangents and cosines, but we haven't used very many application problems. Okay, now, what we're going to do is this, and it goes pretty fast. We're going to go this distance, this arc length from here to here, that arc length. This is pi fourths, and this point, and this is r, and this point right here is r times the square root of 2 over 2, square root of 2 over 2. Questions at this point? Now I'm ready to do what I have to do to prove this thing. And what I'm going to prove, that the radius around here is 2, or not the radius, the circumference. The circumference is equal to 2 pi r. This is what I'm going to show you. Now Archimedes came up with something here, but his was an approximation. And then we get all this pi stuff and like that. And so the calculus will help you to do it exactly. So here we go. I'm going to go arc length. And here's my function. So that's going to be y equals r squared minus x squared to the 1/2. The derivative of that is going to be what?
1/2 r squared minus or negative 1/2
Time
that
2r.
minus 2x.
Okay.
What?
Okay.
Where did the r go?
Yeah, what happened to r?
It's a constant.
Oh, yeah, that's
And the derivative of a constant is 0. Yes.
Is it negative 2x on the other hand?
And this is going to be a negative. Yes. Okay. That's supposed to be negative because see a negative over here? So this simplifies to a negative x over the square root of r squared minus x squared. Are you with me on that? Any questions? Okay, now we're ready to get to work. Here is the length, and that's going to be from here to here, and that's going to give me 1/8 of it, right? So if I go 8 times this, because I'm going to 1/8 way around the circle, I'm going to go from here to here. Okay, and so it's going to be 8 times this, and I'm going to go from 0 to that point which is r square root of 2 over 2, this length, up to here. And I'm taking that arc length. And this is going to be the square root of 1 plus this thing squared. Well, negative squared is a positive, so this is going to be x squared all over r squared minus x squared. Yes?
Why are you going from 0 to r radical 2 over 2 for 0?
Because I can't go from here to here because at the end it's vertical lines. The derivative is not defined at the endpoints. So I'm going to go from this point, this arc length. And you notice that's 1/8 of the way around. Here's 1/8, here's another 1/8, there's an 1/8 here, another one here, and there are 4 more at the bottom.
But then why did you?
Well, why is that your interval? I still don't.
Because I'm taking my arc length from here, which is 0, to over here, which is r pi square root of 2 over 2.
Y times R.
Because it's not a unit circle.
Oh.
Okay? That's why we had to multiply by r. I was thinking of doing it just with the unit circle, then we'd have done square root of 2 over 2. But we're going out r, so I have to multiply by r. Okay? Now, this turns out to be pretty nice in that we need a common denominator here, and I'll just doodle over here a minute, which is r squared minus x squared plus x squared all over r squared minus x squared. Common denominator? See, this is 1 right over here. This is the 1 part. Questions on that? Very important because I'm going to move fast after this. Yes?
Can you redo that slower?
Is here?
Yeah.
Yeah.
Okay. I have to have a common denominator.
Yes, we understand. Yeah.
So this is r squared over r squared minus x squared all over whole quantity.
All over. Okay, so it's r squared over x squared all over minus, or gosh dang it.
Okay.
It's r squared minus x squared all over r squared minus
Yeah.
x squared.
Okay. Now notice these are opposites.
Can't talk.
So I will put another line here. This is going to still give me 0 to r square root of 2 over 2. And this whole quantity is going to be the square root of r squared all over r squared minus x squared. Now what happens here? This r squared can be taken outside of here, and I can dump it way out in the front. This r squared, it's the square root of r squared, so that's going to be an r. So this is going to give me this, 0 to r square root of 2 over 2. And this r comes out here, and this becomes 1 over the square root of r squared minus x squared.
Oh, what do you know?
And that's what I was talking about over here. See this? So, what is the integral here? It's going to be, I need 8 of these, is equal to r sine inverse from 0 to r, oopsie, this is supposed to be x, r like this, r square root of 2 over 2, like that.
XR is what? Oh, sine inverse of that.
Yeah, this is what I have over here. Okay? Now, evaluate this. The bottom here, this one is easy. When I put 0 in here, I get a 0. What's the sine inverse of 0? 0. Where is the sine equal to 0? It's at 0. Okay, so all we have to do is look at this one. And so I have here, this is equal to r times, and if I put this in here, I get sine inverse, and this is r square root of 2 over 2 all over r. See, these two r's cancel. And where is the sine inverse at square root of 2 over 2? Pi over 4. So this is equal to r times pi over 4. Yes?
Okay, when you have AL equals to R sine, what's after that? R sine inverse of what?
Say, what did you say?
The bottom, right there, yeah.
Yeah?
What is that? I can't read that.
This says x over r, like we have up here. Okay? Yes?
So when you said sine inverse of r square root of 2 over 2 all over r, where does that all over r come from?
This r is here.
Yeah.
That's from up here.
That's not graduation gift to you.
That's 13 on the back of the book.
Okay.
Okay? And then,
So then that next step, where does
okay, Okay, here is, this is the x, which is this right up here, over r,
Oh,
and then this r cancels with this r. Okay, then you have nothing more than the sine inverse of square root 2 over 2, which is 45 degrees, or pi fourths. Okay, so my answer here is this, and now I have to multiply this by 8. Okay, and when I do that, L, which is equal to my circumference, is equal to 8, or excuse me, well, excuse me, that isn't what it is. I need, this is what I have, and I need 8 of these. That, I should have changed that. This is this length over here, and I need 8 of those. So I have here r pi over 4, and I need 8 of those. And so you see that that's 2 here, 2 pi r. That cool?
Yeah.
what is this pretty?
Pardon?
What is this pretty?
Circumference of a circle is 2r, 2 pi r. 2 pi r.
Don't you ever notice with the
Yes?
Sine inverse would also be
Yes.
Yeah.
But we're talking about the interval here. Okay. Yes.
Do we have to know this for the exam?
Yes. This one for Wednesday. Okay. Yes.
So we have this proof, but then did you say you're not gonna put the power rule proof on there anymore?
No.
No.
This is the only proof, right?
Yes.
And it's on Wednesday, not tomorrow.
This is on Wednesday. This is the way I thought you could have one that you do arc length, and we won't do any other arc length than this one. Okay. Now. Some of you had some questions on limits, so let's go for your questions now for a little while. I do have another question to do, but I can not do it if I don't have time.
Page 92, number 40.
Okay, my overhead projector just died. I noticed it was going, and it went. And it's not the bulb, it's a socket. What's the question?
92, number 40.
Page 92.
That's one that you never assigned. So like you want us to know how to do it.
Page 90. Did I have 40 in there?
Yeah.
You had it on the review, but you never like assigned it. You just have numbers on an actual assignment.
On page 92, number 40.
Yes.
Yeah.
Wow. 92.
I can do that
I'm not.
for you, but let's not look at it.
39.
Yeah, let's do one of the other ones.
Yeah. Exam work.
Oh, excuse me, we can do that very quickly, yes. I thought we had to do something more. It says, what are the horizontal asymptotes? And you just have to look at the coefficients. Okay? Now, let's do 39 and 40. 39 is going to be 2x, okay, you got the answers 2. Anybody have a question about that?
39?
39 is just 2.
How?
Because I have this.
You want to look at the first term.
And all I do is look at the first coefficient,
Yep.
and it's 2x cubed, and the bottom it's x cubed.
Yeah.
There's 2.
Yeah.
Okay, now let's go to 40. What is, if I take that out of my square root, I have here the square root of 16x to the 4th. Taking that out would be 4x squared.
Over 2x squared.
And then over the bottom you have 2x squared.
So 2.
So it's 2.
What do you do for vertical?
Yeah, vertical.
Okay, now, yes?
Can you do that though, because it's 16x to the 4th plus 64x squared is still in the radical.
Yeah, but we don't have to worry about the other end.
Oh,
Okay, I won't get that on the test though,
okay.
but I thought you could understand. Okay, now you said vertical ones, and how do you get vertical asymptotes?
0 to the bottom.
Always 0 denominators. Is
Set
the
the denominator equal to 0?
You could. Are you? Which one are you gonna look at?
I don't care.
Both of them?
Sure.
Okay, here we go. 3 are x cubed plus 2x squared. That. Take an x squared out, and I get an x plus 2.
So
Right?
negative 2 and 0.
2 and 0. Negative 2 and 0.
Okay.
Those are vertical asymptotes. Okay? Any more questions on this? Pardon? Do. Yes.
Like the techniques for finding limits, how many are there? Is it 4?
No, there are a whole pack of them, lots of them. And then you can also use the definition. And I'm not going to go to the definition with you.
What's the definition?
Like, you
That's
can-
the epsilon delta
Oh, that.
for every, okay?
You
Yeah.
guys know that?
What?
No.
73, 41, or 42
Yeah, what?
with the A's and B's.
42.
What just happened?
What page are we on?
73. 73.
Page 73. Page 73, which ones?
41 and 42.
Yeah, 41.
41 and 42. Okay, 41.
Invited.
We have here x. Boy, I'm surprised I gave you this one. Minus the quantity x minus b all over. No, it's not. Watch, I changed it. Okay? Now, see what happens here. Look what happens here. I'm trying to find the limit here as b or x approaches b. Okay? Now, here's an x minus b and here's an x minus b. So this is going to be x minus b times the quantity x minus b to the what?
49, no.
Minus 1. See that?
Oh, yeah.
And here's x minus b.
Oh.
See, this cancels with this, and now I get x approaching b, no problem, because you have 1 in the denominator.
Where'd your minus 1 come from?
Because you factored it out,
So-
then x minus b out of all.
Can't you just cancel one of the 50 x minus b's with one on the bottom?
That wouldn't work.
If you did, you could, but then you better do this and this and this,
Yeah.
Why would you do that?
because,
Oh, okay, yeah.
you got it? Okay.
Could be 43.
43. 43,
Negative 1.
43.
On page 73 still?
Yes.
Let's see. The top becomes
You could just
4x squared minus 4x minus 1 minus 9. We're gonna have to wait for a little bit on that. Okay, this is supposed to be plus 1, and this is all over x plus 1. Okay? Now, this turns out to be a what?
Negative 8.
Okay, that's a negative 8. And now I can take a 4 out of all that, and I get x squared minus
X minus 2.
minus 2 all over x plus 1. And this becomes now 4 times x plus 1 times x minus 2 all over x plus 1.
How
Cancel.
do you get the, oh, okay, you just did that.
Negative 1.
So it's 4x minus 8 is the final answer?
No, we have, you have to evaluate this at x equals
Negative
a
1.
minus 1.
So you put a negative 1, so you get negative 3 times 6.
Okay?
Can you do 42?
I'm just gonna have to wait. I have to give these guys time now. So just do the rest of them and I'll see you later. Okay, which one?
Can you do 42?
Which, 42 in this group? Now, we can do that in our head.
Okay.
Okay, now you can see, and a while ago we were looking at that, you can take an x plus b out of the bottom and out of the two parts at the top. Now you've got to be careful, your top then becomes,
Can't you just make the top x plus b to the 17th?
no you cannot.
Why not?
Because you're,
You're just adding exponentials. or like your powers?
No. X, okay, let me just do a different one here so you can see that.
Because
Right?
you're gonna do the rule of powers, the rule of
Yeah.
powers. You're gonna do powers.
Never mind, I was thinking multiplication.
You got it? Okay, so we don't have to go there again.
What?
You can only add the powers when you're multiplying. I was wrong, let's get over it.
Grant, I like that.
No. This class I'm a pro with that.
Okay, look what happens.
Cancel.
This one can go all with this and make this a 6, and this a 9.
That's X plus B, the first one.
Yeah,
Yeah.
okay, and now you only have this down here, and now what does the top turn into?
2.
Oopsie, just a second, this is supposed to be an X. Right?
Yeah.
Okay, if X is approaching minus B, what's this turn out to be?
0.
This becomes out. So my answer is?
0. My bad.
I have a question on the,
Okay, just a second, any follow-up on this one?
on when you're saying the end function, I think it is for them, or end behavior, that's what you were saying, end behavior. Do we have to factor that all? Cause like you could, you know how we were able to just see it if it approaches 0 or infinity, we can just do that.
Absolutely. Yes.
So are most of these gonna approach 0? Like, are they giving this easy on the test, or are you gonna beat
They won't be any more difficult than this.
Oh, good.
I think these are pretty tough.
Yeah.
Okay?
Okay.
Chanel?
Page 143, 35, 36.
143. And which one is it?
35 or 37?
35 or 37? Oh, hey, that's a dandy.
I knew
To
you would do
ask.
that.
Okay. 35 or 37 on page 143. What are we going to try to find here?
Tangent line.
Okay, and, okay, 30, you said 35 or 37?
Yes.
Okay, 35 is nice this way, now, and this is over here, plus 2, and A equals 1, okay? Find the equation.
Put a 1 in there.
Find an equation of line tangent to x, okay. What is the derivative of this?
Negative 6x.
Okay, and now we're
Negative 6x.
okay, now in this case, we could also write this, the derivative of this at this point 1, and that's going to turn into negative 6.
That's slow.
Okay, what is the ordered pair on the function here?
Presents just 6.
1 and then
1 comma,
negative 1.
okay, there you are. Are you with me at any part that you're not?
What?
Okay,
What'd you, oh, okay, so your A is like your X, right?
Yes.
Okay, yeah, okay.
yeah, yeah, because in looking at the literature, you find this is the point on the graph, A
Right.
comma that. And so this is the ordered pair, and now we have this, and now we just have to write the equation. Do I have to go any further?
Is that F prime of A you're putting there up top? No,
Here?
is that F prime
No,
of A?
no, no, that's to get this point over here,
So like,
which is just substituted right in here. Pardon?
what's the equation?
The equation, now I'm not gonna simplify it all the way, you can go there. It's gonna be y plus 1 equals a negative 6 times x minus 1.
Yep.
Okay? Shannon?
Do we have to know derivatives of inverse trig functions other than
Hey,
the one?
I need it, so what, once again?
Do we have to know the derivatives of the inverse trig functions other than what we used for that proof?
The proof today, no. We know they exist and we'd have to go find them. Brianna?
Wait, so you said we did not, so like if like the power rule and proof, we just need to know how to use the power rule?
Just know how to use the power rule.
What is the power rule again?
It's N, X, N minus 1.
Okay, what?
It's just the,
How you
find
define the
derivative. Like,
derivative.
X to the fourth is 4x to the third.
Oh. It's just figure and stuff.
Okay, next question.
Soccer players.
153. What do you do for the table again?
153. Which one are you looking at?
64.
64. It says, I want the derivative of that, and that's a product rule.
Yep.
Okay, now I have here dx of f of x, g of x. Okay, and what does that turn out to be? F prime at x, g at x, plus g prime of x, f of x.
Okay, so is 65 f of x minus g of x?
Low d high to low over low square.
That's a quotient rule.
Okay, quotient rule.
So that'd be like G to
Low D high minus high D low.
So
low, and then derivative of the high, plus
You do 67
high,
out of those
low
things.
over low square.
So I don't get the right. That's just the quotient rule, right?
yeah, low d high.
Low D high minus high
That's
D
okay, we
low.
can just not do that.
Okay?
Can you do
Yes. 261. 261. 261. Oh, one of those. Which one? 10. Okay. And let's take a look at that thing. And we have a rectangular pen. Build one side against the barn, 200 meters of fence, and into 3 sides of the pen. Okay, so I think what we have here, I read it quite quickly, and we're going to have this, aren't we? Is that right?
One more.
We have 4 pins?
Yes, sir.
Okay, okay, maybe I read it more carefully. This, okay, let me just see what it says. A rectangular pin.
That's letter B. So letter
Yeah, A is different than B.
A is easy.
Yeah, can you just do letter B?
Okay, guys, so we don't waste time. You wanted B?
Yeah.
Oh, she wanted B,
That is B.
okay? Okay, arrange your plans to make 4 identical adjacent rectangular pins, each with an area of 100 meters. And we're along the barn. Okay, so each of these is 100. And let's see, how do we do that?
X, Y, Y, Y.
This is going to be X, Y, 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 and these are X's. Right? And so we know our restraint is what? X times Y equals 100. And how much fence are we going to use? 5x plus 4y. And, okay? Yep.
Okay, so isn't that for each one? So we're gonna do 2x.
That's what we need to do. You could do that too, and then.
Why'd you do it 580?
Well, I need a fence here, here, here,
Yeah, but
here, and here.
each individual area is 100. So what if the total area do you want 100?
Oh, yes.
Okay, so.
Because, but this is X and this is Y, and that's going to equal 100.
So x, y equals 100.
So we're using the area of the little one and then the perimeter of the big one.
It's the perimeter of the big one. And the perimeter we're looking at is this, this, and this.
Yeah.
And we have to also fence the inside.
Okay.
So we have, and we don't have anything along the top, okay? And so this we have, whatever, and we want to just, we'll say we're going to maximize that. Oh. Okay? And so at this point, we get here, y equals 100 over x. So we have here plus.
Hope you like.
Now do you need more help? Okay, now what we're going to do. To find the minimum, we're going to first derivative, right? Oops, it's supposed to be an x. And the first derivative of this is
5 minus 400 over x squared.
5x squared equals
because this turns out to be.
Oh, minus, yeah, okay.
Wait, how'd you get rid of that x? You multiplied the inverse or what?
No, I'm taking the derivative.
Well, that's crazy. Okay.
Okay, and now this is my first derivative of my function, and I'm going to do what to that?
use the table.
Take the double derivative.
So you do the second derivative.
Second derivative, if it's a negative, you know it's maximum, if it's positive, it's minimum.
I like that.
How am I going to find the value?
You just,
400x squared.
Solve for x squared.
Okay, we're going to solve, or set this equal to 0, solve for it.
Oh, yeah.
4 radical 8.
Okay.
Yeah.
Are you sure?
Yeah.
And so I get
Good job.
X.
80 equals x.
x squared equals 80.
Yep.
And so we lined up with this. Yes, oh, I didn't do that yet. That's just to prove that it's a, we use a second derivative test to find out if it's a max or a min. Okay.
If it's a max or a min.
If it's
If it's negative, it's a max. If it's positive, it's a min.
simple as that.
Okay, Shannon?
On page
No.
279, with the value theory, we have this doing number 19. Yes. I never assigned that. Did you see it 17?
279, you said?
Yeah. Great question, Shannon.
And which one?
You have us doing number 19, but that's like an inverse true one. It's good.
Did I really put that in there?
Yes.
How do you do
And
15?
you never assigned it. You assigned
No.
17. So that's not the theory question.
I'm sorry about that. We could do it, but
No.
we don't want to. Yes.
Can you do 17 on page?
Oh, no, we're on this page. Is this
Good night.
You want to see anything more on 15 and 17?
No.
On one page?
No, you don't.
I'm
279.
279? Can we do number 9?
17? Okay, here we go. We have this curve, like this, that's e to the x, and we want to find, we're going to go from 0 to over here, which is ln of 4, and so we're going to go here, and you notice this slope here, and we're going to have another slope here like this. And I want to find where these two slopes are the same. Okay? Now, this point is going to be what?
0.
0 comma 1 up. Okay? This one is going to be ln of 4 comma how high?
4.
4. Okay? Now the slope of this line here, this top line, is going to be 4 minus 1 all over ln of 4.
Because otherwise you take ln of 4 minus 0, right?
Yeah.
It's like rise over run, right?
Yeah.
Right, okay.
Okay?
Ready,
Now,
break.
now look what we have to do.
Something.
I have to find this point right down here. This is the C point where this slope is the same as this one to my curve. And here's my function, f of x equals e to the x, right? And I want to find out, what's this derivative?
E to the x.
See, that's a little confusing, or it makes it also very easy. And I want to see where this is equal to 3 over ln of 4. Okay? And I want to find out where x is.
Okay.
Okay? And so I have ln, I have e to the x equals 3 over ln of 4.
Take the ln.
Yeah, we could do that. Is that the easiest way?
Yeah, so then x is just equal to the ln of
ln of e to the x equals ln of 3 over ln of 4.
Yep.
This comes out, so that's what x is equal to.
And you don't simplify it more than that?
Don't have to, that's the exact answer.
Okay.
So all you have to do is give x is equal to that.
Yeah, this here.
Good.
Okay. Ooh, this one, and then we'll go over here. Yeah.
Rate of electric flow or whatever,
Like 214 bars we're
Yes.
talking about?
Yeah.
214. 214.
We gotta do 5, 9, or 17.
214, which one?
Number 17.
Number 17. Is that the one you want?
Yes.
Yep, sure.
Yes.
You did that one.
Yeah.
Okay, here we go.
On 215.
You were going so fast.
We never did that.
Direct camera.
Notice what we have here. This is going to be x. This is going to be y. This is my wall, my 13-foot ladder, and we're doing a Pythagorean triple, I'm sure.
I felt 13.
And it says the ladder is being pulled, begins pulling the ladder, the foot of the ladder away from the wall at, okay, this is going this way at 1/2 feet per second. Okay, that's going that way. How fast is the top? In other words, how fast is this coming down here? Like this? When the ladder is 5 feet from the wall. Okay, now watch what we have here. It goes pretty fast. Hang in.
It's 5 feet off.
Okay, we know that x squared plus y squared equals 13 squared.
Yes.
Right.
Okay, now, also, we know that dx dt equals 1/2. We have a dy dt, which we're looking to find. We're going to find that. Okay? Hang in here a minute. I'll be finished quickly. This is 5. At this point, it's going to be 12. Now look what happens here. What is the differential of this? 2x dx dt
All the 2's cancel.
plus 2y
dy dt.
equals 0. Okay? Now, you know these parts and you know all this, you find this.
Yeah.
Yep.
Because that is equal to 5.
dx
So
dt
this-
is 0.5, right?
And this is going to be times 1/2. Yeah. And this
Times
is going to be plus
24.
24. And then you find that.
Yep.
Okay, thank you. Number 9.
It's gonna be a negative
Hey, are you gonna be here
because
tomorrow morning?
and
I didn't intend to be.
Okay. What about Wednesday morning though?
I didn't intend